So let's start from geometrical definition of derivative. This is our function with tangent line and second line going through the point of interest x. Also second line cross our function at the point x plus delta x. Respectively, we will have f at x and f at x plus delta x. From this picture, it's very easy to understand the derivative in the point x. The less delta x we have, the closest second line is to our tangent line. So let's write it in formula. df over dx equal limit from f at x plus delta x minus f at x divided by delta x when delta x is approaching to 0. Now we can talk about border problem. Let's imagine that we know function in these dots. Then, according to our definition, in order to calculate derivative in the point I, we need to know the function in the point I and I plus 1, or x and delta x. And these points are within our domain. So for every point we need to know point and the next point. But what about the point on the border of this domain? So we need to know the value of the function beyond the border. The calculation of the function value beyond our domain is so-called border problem. Today we are really lucky because we can easily calculate the value of our function beyond our domain. Now we need to create our domain for calculation. So we will calculate from minus 10 till plus 10. And we will call this points start x and end x. This will be user-defined values. So one small step will be delta x or 1. And this is our complete domain with n dots inside. At the left and at the right it will be border area with user-defined border size, where we need to calculate our function as well. So at the bottom, below the line, it will be our physical values, and above the line it will be our indexes values, which we will use for indexing of our arrays. First of all, we need to include NumPy and matplotlib as the libraries for our calculation. Second, we need to define function f for calculate values of our function. So let's do sine as an example. Secondly, we need to calculate derivative for compare with our results. So the derivative of sine is cosine. So now we will define our parameters. First of all, we need to have border of size 1, then start of domain minus 10, end of domain it will be 10, number of elements 100, and we will create structure defining our x-axis. So we have border there, start point 0, end point will be number of our points plus double border size. Our domain left point will be border, index of the right point will be number of elements plus border, and step of the domain it will be physical value, end of domain minus start of domain divided by number of dots in the domain. That's it. Now we can create x space with parameters. So we will start from physical start of our domain minus border size, which is dx times number of dots in the border. Endpoint will be end of the domain plus delta x times size of the border. And step is delta x. Now we will calculate our function y equal f from x. And let's plot it to see that everything is alright. So we will plot it with matplotlib x, y, color yellow, and let's call it function. So now let's write our labels or legend at the left top corner and draw the function is our plt show function. So let's run it. Oh, sorry, it's an error. Range should have one error. Okay, so it's proper function of sine. Next one, we will calculate theoretical derivative to compare with our results. Just call function df and let's plot it. So now we will plot it with black color and name it derivative. Let's see. Okay, this looks alright as a cosine. So now let's calculate our derivatives, u capital. So we'll call function derivative from function y, and x it's the domain description. So we need to define this function as well. So let's define function for calculating of our derivative. Parameter will be value of the function and the description of the domain. We will define array for storage of our derivative. We will make it empty like our function to make the same size and the same values. Then it's very important to understand that this is NumPy and we should use matrices to calculate derivative. So we will start from the left side towards the right side of the domain. And in these dots the value will be, according to our formula, function from left to right but with shift 1 minus value of this function in the same dot divided by delta x. And we will return this resulting array. This is our derivative. So let's plot it. So now we will plot it as a small crosses in every calculated point to see the difference and call it numerical. But it's very important to understand that this function is defined only from left to right area of our domain. So we need to plot only this area. So let's see what's happened. Yes, perfect. You can see that our crosses is slightly shifted left from our real function, but I will explain it in the next video. And last very important thing, we need to move the creation of empty array for derivative out of from the function of derivative calculation, just in case in the future we will calculate this derivative many times. We should not redeclare this array many times. That's it. We make our first code for calculating numerical derivative.